In this video, we're going to be discussing and really looking at the sub-agent multi-agent pattern. This is going to be the first multi-agent system pattern that we're going to be looking at, the sub-agents pattern. Now imagine you're the HR at a company. So this is you, HR. And the boss says, let's get a text. The boss says, it's Susie's birthday. Make sure you organize something special for her. So, as the HR, you get into action. What would we need for Susie's birthday? Definitely won't want to miss out on a cake. So you need to call a baker. You need to call a baker to get a cake. Now what next? We need balloons. We need to have the staff room decorated. So yeah, definitely we need a decorator or an event planner or whatever. Let's just say a decorator. Let's call them that. A decorator to make sure that the staff room is decorated and everything is nice for Susie's birthday. Then we'd like to eat something. So let's get a caterer. Let's use blue for that. So let's get a caterer to take care of that. So you're calling these guys, and as you prepare, you communicate with the baker, get the status of the cake. You guys communicate back and forth. The baker gets back to you, gives you the progress report, and definitely tells you when it's done. So you get that information. Then you also communicate with the decorator, who also gives you their bill. You negotiate to get everything done. They implement. They get back to you. All this communication going on. Sometimes simultaneous, sometimes not simultaneous, but communication is going on between you and these guys. And at the end of the day, you make sure that everything, all their tasks, is harmonized, and Susie gets a birthday. So the CEO gave you a task to plan Susie's birthday, and you have just executed it. Say plan Susie's birthday, and you have just executed it by calling on different specialists to handle the tasks. You are managing the communication back and forth with all of them, and you are making sure that everything is harmonized. The decorator doesn't go and decorate the yard instead of the staff room. The caterer gets the food there on time, and you make sure that you give the caterer necessary information, how many people are going to be eating, some extra plates in case some people bring guests along. You make sure that the baker bakes the correct type of cake you want, doesn't misspell Susie's name, delivers it on time. So you manage all that, you coordinate all that, and at the end of the day, you can get back to the CEO. These guys don't talk to the CEO. You get back to the CEO on the status of Susie's plan. When the CEO asks you, what's the status of Susie's birthday plan? How is it going? You get to respond, fine. Oh, the baker will deliver so time. Oh, we'll have the room decorated, or the room is already decorated. The food has been delivered, and all those kind of stuff. You get to communicate with the CEO. These guys don't communicate with the CEO. These guys communicate with you, and you synchronize all the operations and get back to the CEO. This is exactly how the sub-agent pattern works. It's a multi-agent system where you have a central main agent who coordinates specialized sub-agents, synchronizes their work, and makes sure that the appropriate response gets back to the user. So here we have HR. You as the HR. In the sub-agent system, you are the coordinator. The baker is a sub-agent, because sub-agent 1. The decorator is another sub-agent, because sub-agent 2. And the caterer is another sub-agent. I'll call the caterer sub-agent 3. Yeah, that is how the sub-agent pattern works. That's basically how the sub-agent pattern works. Now let us look at the characteristics of this pattern. the attributes you're going to see in a multi-agent architecture, and you'll be like, yeah, this is using sub-agents. This is using the sub-agent pattern. And the first is centralized control. Centralized control. That's the first thing. Let me write characteristics here. Characteristics. Yeah, be cool and do X. So characteristics of the sub-agent pattern. The first is centralized control. There is a main agent, who is the coordinator. There's a main agent that makes all the routing and delegation decisions. All the routing and delegation decisions is made by this main coordinator agent. Not this guy, not this guy, not this guy. This guy makes all the decisions. So that's the first thing. One main agent is the one leading the orchestra. That's the first thing. The second thing, and this is from an implementation standpoint, is that your sub-agents are tools. Your sub-agents, while being agents, let me spell this correctly. Your sub-agents, while being agents, are implemented as tools. They're implemented as tools. So what you do is that you create these sub-agents with create agent or with a land graph. You create them and you expose them as a tool to the main agent. You wrap them as a tool. You use a tool definition, you create a function, you call the agent within the tool, you return its response, and then you can give that tool to the coordinating agent, the main agent. Yeah, that is a very key part of using the sub-agents pattern. Your sub-agents are exposed to the main agents as a tool, as tools rather. They are exposed to the main agent as tools. Now, the third characteristic, which I have discussed, but we're going to emphasize again, is that there's no direct user interaction between your sub-agents and your user. Yeah. Between your sub-agents and the user, giving you the task, giving you the query, there is no communication between them. There's none. There's none. They can't go behind you to communicate with the user. So this central agent is the one leading the pack. These guys don't get to communicate with the user directly. They don't get to communicate with the user directly. Just as these guys that you have contracted for Susie's birthday don't communicate with the CEO. They don't communicate with the CEO except you don't get them paid and they decide to go rogue on you. Yeah, which is definitely within their rights. But yeah, they don't have any reason to communicate with the CEO. They have any reason to communicate with the CEO. You manage everything, payments and all that. Another thing, another characteristic of this design pattern is that there is context isolation. Context isolation. Now, what this means is that each sub-agent works in a fresh context. Each sub-agent works in a fresh context. No memory of past calls. You call them once, they do their work, they return it. You don't inquire of their work like, yeah, those stuff I give to you, what about they're not going to. You get to keep all the context. Yeah, you get to keep all the information. You get to keep all the state. So let's say you tell this guy that you want red velvet cake. It makes red velvet cake. If the CEO asks you which type of cake did we make, don't go and ask this guy. He doesn't remember anymore. He doesn't remember. You have to remember that it's red velvet and respond to the CEO. And the CEO says, yeah, I would prefer a chocolate cake instead. Then you have to go back and give this guy new instructions for a chocolate cake. Give it new instructions for a chocolate cake. It can't reference any previous information about this. By the way, why am I pointing to the caterer for cake? Sorry. cake instructions go to the baker. Cake instructions go to the baker. Sorry about that. So yeah, there's context isolations, and these agents are stateless. They are stateless. They don't remember past invocations. No, they don't remember previous invocations. So that's another thing you need to keep in mind. And also, they are isolated from each other. This guy doesn't know what this guy is doing. Yeah, the baker doesn't know what the decorator is doing. the caterer doesn't know what the decorator is doing. So you are the one to hold all that information and make sure that you give the decorator the right information so that it doesn't mess up whatever the caterer brings. For example, the staff room is decorated, but there's nowhere to put the cake. Yeah, you are the one that is responsible for that. You are the one that didn't give the correct instructions for the caterer to be able to, or rather for the decorator to be able to make sure that, yeah, there should be a stand for the cake. So that the last one is result synthesis. Result synthesis, which we have also kind of discussed, meaning that you are to collate everything that comes from these guys. Everything that comes from these guys, you are responsible for collating everything, making it make sense, and reporting it back to the user. The coordinator is responsible, the main agent is responsible for combining all the outputs from the sub-agent into a coherent response for the user. So yeah, that is the final characteristics that we're going to be looking at. Now let us look at the process flow, and we don't need to leave this diagram to better understand the process flow, but we're going to look at it in stages, each stage of how the entire process flows through this multi-agent pattern, the sub-agents pattern. First, the request is received. So a user sends query to the system, to the entire multi-agent system, sends a query, and that query is received by the main agent. The main agent receives this query. Now the main agent will then make a routing decision. It has to make a routing decision. So what it first does is that it analyzes the request. And decides which sub-agents to call. And this is very important because it doesn't have to call everybody. The fact that it has a baker, a decorator, a caterer, what if it was just a simple birthday that needs to happen in like 15 minutes? So we're not going to have time to sit down and eat. So with that, even though it has the contact of a caterer, it doesn't need to call. The caterer, just call the baker and the decorator. Sometimes you can even keep it so simple, you will just only call a baker. We just want to snap a few pictures with our name on the cake, blow some candles, and be done. Then it will just simply call the baker. So the context of the task also determines who is called. Not everybody has to be called. So it makes that routing decision and decides who to call. And remember, they are wrapped as tools, so this main agent calls them as tools, but they are actually sub-agents. So what happens? It calls the sub-agent it needs to call, they execute their tasks, and they all return their responses. It's a one and done thing for them. They get the call, they operate, and they return, and their entire context is cleared. They don't have any memory of what just happened. So that happens. All the results flow back to the main coordinator based on how many sub-agents actually worked on it. Then the main agent will then synthesize. So it would combine all the results and then provide a final response. And hold all the context. If it's using a checkpointer, it will hold that memory, and you can requery it. But these guys don't get to hold the memory. He manages all the information and all the flow. So that's how that happens. Now, before we proceed to our next talking point, I want to go back to this context isolation and why it matters in sub-agents pattern. Because you might want to ask yourself, why is it that these guys can't keep context? Wouldn't it be nice for them to keep context? So let's discuss that. First, the fact that you have context isolation prevents context bloat in sub-agents. We're trying to manage context windows, so we want to trust the coordinating agent to give them what they want, to give them all the context they want as needed. So we don't want to store context here and bloat up the whole context window for this sub-agent. It will be very, very redundant and wasteful. So we want this guy is going to be responsible for all that intelligence to give these guys exactly what they need. Even if they need to refer to something that happened previously, it should bundle it up in the context so that they can refer to that to provide grounded responses. So yeah, that's the first thing. Number two, it keeps them focused. it keeps them focused on only the context they need. If you are storing extra context here, they would always refer to it. And some of those context information is already stale. They don't need it. So it's better to clear them each time so that they only get what they need. And this guy is going to be doing a lot of heavy lifting. Yeah, this guy is going to be doing a lot of heavy lifting. So this guy is going to be the one to make sure that they get only what they need. Subagents can be confused by bloated context. They can be confused by irrelevant history. So you don't want to pack anything inside that will make sure that they don't do their work in a focused manner. And we're going to delegate all that heavy lifting to the coordinating agent. So basically, that is why we want to keep our sub-agents stateless in this particular design pattern. Now, let us talk about some design decisions. I think I can still have that here. Design decisions. Some design decisions when working with let me put asterisks here to show that these are the headers. So just something there. Yeah, something like that. So characteristics, here we have design decisions. Yeah, okay. That should work. Okay. So what are some design decisions that we need to make when we are using the sub-agents pattern? The first thing we need to ask ourselves is that, do we want the execution of each sub-agent to be synchronous or asynchronous? So sync versus async. Sync versus async. Do we want it to be synchronous or asynchronous? If it's synchronous, then the main agent would have to wait for a sub-agent to complete before it calls another sub-agent. It will have to wait for it to complete before it calls another sub-agent. Now, this is useful when you need the results of a particular sub-agent before you call the other one. Maybe the baker, probably the decorator is looking for the right table or the right team for the table that will carry the cake, something like that. I'm not an expert. And the baker needs to be done so that you will know, yeah, this is the size of the cake and this is what to weigh and everything, so that the information can be passed to the decorator and decorator knows the appropriate type of cake stand to bring. So yeah, that can be useful. Sometimes these tasks are dependent, have to happen in a particular order. Then you would need to run stuff asynchronously. So that can happen. That can happen. So you have to make that decision to either run this guy synchronously or asynchronously. But because you define them as tools, a lot of times your coordinator is going to be making that decision for you. Anything that can be run simultaneously, to run them simultaneously. Anything that has to wait would wait and would run immediately after the dependents are done. You should also try and provide something like that in the set of instructions that you are giving to your coordinator. So in a situation where you want to run things asynchronously, that you run things asynchronously, the main agent is just going to continue while the sub-agents do their work in the background. Just going to continue. For example, the baker and the caterer can just keep working. Yeah, the baker and the caterer can keep working, and they don't have to block each other. The baker and the caterer don't have to block each other. This is very, very important for long-running tasks. If you have any long-running independent tasks, you want to make sure that you're running them asynchronously. For example, you are doing some research. You are compiling a report and stuff like that. You're researching different sources to get information. You should run that asynchronously. So that's one thing. The second is what each sub-agent receives. What if sub-agent receives? Now, a lot of this, I want to point out at this point, no pun intended. I want to point out at this point that a lot of these decisions are more important when you are doing things from scratch, or you're doing a custom flow, doing things from scratch, doing them with graphs and all that. If you use the create agent, react agent, it would make a lot of these decisions for you. But if you are doing things from scratch, which you might have to do a couple of times, you need to these decisions are very, very important. So you want to decide which information goes to each sub-agent. You can decide to pass them the query, only the query. You can just take the whole context and just pass them the query. Yeah, this is what the user wants. This is what you have to do. So it just gets a specific task question Like for the baker, you just simply tell the baker, bake me a 3-layer red velvet cake with buttercream frosting. So you just give them the specific instructions they need. So sometimes you just pass only the query. Other times you want to pass the query and some context. Like I said, they are stateless, so any context they need has to come from you. So sometimes you just pass them the task they need to handle, or you can pass them that task with some context. Pass them that task with some context. That's another thing. So they can have the sub agent can get a subset of the whole conversation history, or you can just give them the full access. Same full access you have, you give it to them. That would probably not be needed most of the time to pass the entire set of state keys to them, and also it can lead to tight integration. Sometimes that is needed. Sometimes you need to tightly couple them, but most of the time you wouldn't. So, but yeah, you have the ability to do that. You have the ability to pass the full state to your sub agent. So that's the other decision you need to make. Should you pass the query, just the query? Should you pass the query and the context and some context, or should you just give them the entire state? You just give them the entire state with all the state keys, and they have access to everything they need. Now, the third decision you need to make is what the main agent would send back to the user. What the main agent sends back. What the main agent is going to send back. You need to make that decision also. You might just assume isn't not just the answer, it just sends the answer back, sends the whole report back. No, sometimes you can send other things. For example, we know you can send the final answer, so you just send the conclusion. You can send the conclusion of the sub agents. You can just send them to the user. Sometimes you want to also send the reasoning why it was so. So you can send the reasoning behind it. That's your result plus how the sub agent got there, how they got there. This happens when the main agent needs to validate why certain things are the way they are. So you would want to send the reasoning back to the user. And sometimes, for some reason, if you are probably running this multi-agent system within another system, you might want to send the full message history, everything the sub-agents did. You will want to send it back, because if you're working within another system or you are interacting with another API, full transparency is going to be needed. Full transparency is often going to be needed, and it also helps you to properly debug. You have all the data you need to debug the activities that happen. So that's another thing you need to decide. What do you want to send back? What are the things you want to send back? These are part of the things that you can put in the instructions, system instructions, or instructions of your create agent, and also defining your graphs. What do you want to send back to the user? So those are decisions that you need to make. Now that we've looked at all this, let us talk about benefits and trade-offs. Yeah, benefits and trade-offs. What benefits do we have using this pattern, and what are we foregoing or we need to be aware of? Some caveats, some gotchas. Just going to put the title here, and this will be benefits and trade-offs. Benefits and trade-offs. Let's fix this. Okay. So sub-agent pattern, what are the benefits and trade-offs of using this pattern? Let's start with benefits. So I'll put benefits here. Keep writing benefits for some reason. Okay, benefits and trade-offs. Trade-offs. So benefits and trade-offs of this pattern. The first benefit, let's use large text here, is the clear separation of concerns. Clear separation of concerns. That's the very first benefit. So each sub-agent handles one domain and they handle it well. Their information is not bleeding into another agent. It's not causing confusion for another agent. Each agent gets what they need from the main agent. Each sub-agent gets what they need from the main agent. They focus on their domain. They run their task, they do it well. So that's one thing. The second benefit is that you have centralized orchestration. centralized orchestration. Because imagine as the CEO, you have to be the one dealing with the baker, dealing with the caterer, dealing with the design. That's a lot. It's better your HR takes care of it. So you just have to talk to your HR. Your HR gives you back the information. That's a whole lot less to have to deal with, a whole lot less chaos. So there's centralized orchestration. One place controls all the workflow decisions. If you want to find out where anything went wrong, decision-wise, orchestration-wise, routing-wise, is that guy. That guy is to account for it. That guy is to answer for it. You know specifically where to go to debug stuff. So that is another big advantage of this pattern. We've talked about context isolation. So just bringing that back, it is also a benefit. Context is well isolated between subagents. There's also parallel execution, which, while it is optional, it is possible. So anything that needs to be executed in parallel will be executed in parallel without getting any latency hits from that. So you can invoke multiple subagents simultaneously. Also, and this is for developer experience, your teams can work on different agents. So you have independent development. So you can You can dedicate different teams or even different people. It can just be Frank. Frank is responsible for the caterer agent. Linda is responsible for the decorator agent, and John is responsible for the baker agent. Yeah, so it can even just be a single developer per agent, and it can be teams depending on how big your development department is. So there's that. You also get easier testing. Easy is relative, but at least compared to some that we might be seeing later, or rather that we're going to be seeing later, it's easier to test. You can test your subagents in isolation, and you can also test them together, integration. So you can do unit tests and you can do integration tests for the entire multi-agent system. Then, just like the microservices architecture, which some people love to hate, it is scalable. It is scalable. And this is because you can add new subagents without changing existing ones. You can increase the capabilities of your subagents. You can better their prompts. You can better their tools. And you can just make them better in every way. And you can also remove. You can also do addition by subtraction. You can remove stuff just to make sure the system is good. All the while not disrupting the entire system. So that's another thing. We also have better tool selection. Better tool selection. Like I said in the beginning, especially when we're discussing multi-agent systems, when you give an agent just the tool it needs for a specific task, then it's going to make better decisions. It's going to make better decisions because each subagent has fewer tools, more relevant tools, so their decision is going to be razor sharp. So you have that. Then this might sound redundant, but there is modular maintenance. No, it's not redundant at all. Yeah, there's modular maintenance. It kind of ties into the development team thing, I think, the independent development. But yeah, modular maintenance. You can update each sub-agent without affecting others. Everything is modular. It's a modular system, and you can just take one sub-agent, improve it, or remove some tools, add some tools, and it will not affect others. So that's a very, very good thing to have. Now let us talk about trade-offs. What are the trade-offs? What should we be aware of? The first trade-off is definitely all the extra LLM calls. All the extra LLM calls, because so this is what happens. Your main agent makes a call and decides, yeah, I need to call this subagent. Then he calls that subagent, who also makes a call and does his task and returns the result to the main agent. Then the main agent has to still take that information and make a call, an LLM call, to make sense of it. So it just added an extra LLM call. Just added an extra LLM call to it. So let's use diagram. We don't have so much space for diagram, but let's just use diagram. So this is your main agent. It calls, it makes an LLM call to determine that, yeah, I need to go to this particular subagent. Okay, cool. Go to the subagent. Go to the subagent. Now, this subagent does its work. It makes its own call to do its work. Probably call some tools too, but yeah, just makes its own call to do the work. And that's the second call, the second LLM call. Then it then returns back his result. Pull this up a little bit. Then returns back his result to the main guy. Returns back his result to the main guy. Now, the main guy, instead of just passing the result in a single agent system, just passes the result, it still needs to make another LLM call to analyze what this guy got back. You need to make that extra LLM call. So there's an extra LLM call with every single sub-agent that this main agent interacts with. So yeah, extra LLM calls are part of the overhead that you have to deal with. So you should have enough tokens to accommodate that. Because in this pattern, there's really no way to work around it. The only way to work around it is to accept it. Just accept the cost. Yeah. So next, we have no direct user interaction. No direct user interaction. So the subagents, this has to do with subagents. The subagents can't ask the user for clarification. So for example, if the baker needs to probably just make a red velvet cake and she was not giving specifications as to the width of the cake, she can't call the CEO. You can't call the CEO. No, you can't call the CEO. You have to call ask HR. Ask HR. So there's no direct interaction between the user and the subagent. So the subagent cannot directly ask the user for more clarification. Now, one way you can mitigate this is if you use human in the loop interrupt. You interrupt with an human in the loop call, then the user can provide more information, and that information goes directly to the subagent. Or another way is if the main agent asks. If the main agent asks, yeah, you can get that information and pass it to the subagent. Probably before the task gets to the subagent, the main agent realizes that, yeah, CEO, how big should the cake be? I don't want to bring a 3-layer cake and you'll be like, are we doing a wedding? The CEO is like, yeah, just a I think 3-inch or 4. Just make it this simple and all that. So the main agent gets all the information ahead before calling the subagent. So that's the only way you can mitigate this. Else, there's no other way. The subagents cannot interact with the user. Only the main agent can interact with the user. Also, like we discussed, subagents are stateless. Subagents are stateless. And while we have discussed the benefits of that, definitely there are also disadvantages to that. So they can't remember previous calls. And the best you can do is that the main agent will pass necessary context. Except from the conversation history, any other context from any other source, so that the sub-agent can use that to sure. Okay, let me go in this direction. So yeah, that's the only way you can mitigate that. Definitely increased latency because of all the back and forth. So increased latency because you have to get in this report back, forth, and all that. So yeah, for example, like you're trying to get paid. You're trying to get paid as the sub-agent. You're the baker. You're trying to get paid. You first have to submit an invoice to the HR. Then the HR has to submit it to the CEO. Then CEO has to approve. Then has to send it to the HR. Then the HR has to call the oh my god. But if you're just talking directly with the CEO, it might even pay you out of pocket. It can be that fast and direct. So yeah, increased latency. The only way you can mitigate any type of latency issue is to use parallelism where necessary, or where possible rather. Where possible, use that parallelism. Yeah, also where necessary, use parallelism. That's the only place you can mitigate the the latency bottlenecks. But you can't bypass the back and forth communication that has to go on between the main agent and the sub-agent. Then all the extra calls will definitely give you higher costs because of all the tokens you'll be spending back and forth, or the back and forth communication between the main agent and the sub-agent. More tokens are going to be processed. You also have to accept this cost. There's no mitigation strategy. You have to accept this cost, but it's worth it for complex orchestration. So there's always a cost budget to every type of direction you choose to go. There's no perfect pattern. There's no perfect system. Another thing is synthesis complexity. Your main agent should be smart enough to know how to synthesize the information from the different agents, or rather from the different sub-agents. It has to be smart enough to do this. LLMs are getting powerful these days, so they kind of know what to do if you give them good prompting, because that's the only mitigation. Strong synthesis prompting. You have to give them good prompting to make sure that they know what to do. They must combine all the results in a way that is not conflicting. For example, with the HR analogy, she might not be a cake expert, a catering expert, or a decor expert, but she has to have general knowledge about all these things. She has to have general knowledge about all these things. Else, will she go back to... You can't be asking your CEO some questions. So you have to take charge. You have to have agency over the sub-agents, and you have to make sure that you direct all those sub-agents, the caterer, the baker, in a way that all their activities flow. Everything can't just be scattered and all over the place. You're not doing your job well. Another thing is routing errors. And this would always happen when you have ambiguous prompts. Your main agent might go and call the wrong sub-agent. If you have ambiguous descriptions in your tool descriptions for the sub-agent, you remember you wrap them around the tool, or you have ambiguous prompts inside your sub-agent, your main agent is not going to know which guy does what. So you can't just say bakes cake, or just get stuff done. You can't give such kind of vague stuff. You have to properly define what the sub-agents do, have clear boundaries between what each person does. We should not say cake and you go and call it caterer. that would be catastrophic. So there should be clear boundaries between what they do, and this can be done through clear tool descriptions and very, very good prompting. You don't want to be calling the wrong guys or missing out some guys that you're supposed to call. So that's a very important step. So yeah, those are our benefits and trade-offs. Let's look at when to use this pattern. When do we use this pattern? New frame. Get this out of here. It's 200. 100, no, 100. So when do we use this pattern? When do we use the sub-agents pattern? Or when to use sub-agents? When to use sub-agents? Now, we're going to be looking at this under two different headings, rather. So, when to use and common use cases. So, when to use, first, when you have distinct specialist domains. When you have distinct specialist domains, you use sub-agents. It's kind of the argument to use multi-agent systems too, but yeah, definitely where sub-agents is a subset of sub-agents. So yeah, when you have distinct specialist domains, you want to use sub-agents. They're not, okay, I think what the better way to describe it is that when they are not dependent, when electrician, plumber, this thing, they are related. Not that they're not related, but they're not dependent. So they're distinct specialist domains. Then use sub-agents. Also, when sub-agents don't need to talk to the user. Don't need to talk to the user. So for example, in the HR example, the baker does not need to talk to the CEO. The caterer does not need to talk to the CEO. So definitely you need a coordinator to just coordinate all of them and get things done. So that's another aspect when you use sub-agents. You also use them when you need centralized control. Centralized control, you want someone to just handle it. So yeah, you want that. You want the context to be isolated. You need parallel execution Not all the time, but when it's necessary, and you know why that is important later, because the sub-agents pattern is very close to the routing pattern, but the routing pattern parallelism is not an option. So, but for the sub-agents pattern, parallelism is an option. You can use it, you cannot use it. Only when it improves performance, then you use it. So, when you want different teams, part of the benefits, when you want different teams to own different agents, and different teams to own different agents, and also when you need clear separation for testing and maintenance. When you need clear separation for testing and maintenance, yeah, use it. So yeah, this is your rule of thumb to know when you need this pattern. To wrap things up, let us look at common use cases. Let's look at common use cases in the real world where this is used. First, personal assistant. Yeah, personal assistant. Get my flights booked, get my hotel reservations, get my script written for the talk I have to give. Yeah, personal assistant. You want to have a calendar agent, you want to have an email agent, you want to have a task agent, specialized agent for different things. Yeah, this is very amazing for a personal assistant. There's a course I'm going to be releasing soon, most likely after this one, where we get to build ChatGPT from scratch. And I'm seeing the sub-agents pattern as kind of like the best pattern for this, because all these chatbots are basically like personal assistants. So the chatbot gets to talk to you, but whenever you need to do any specialized thing, it will just use a sub-agent underneath. Do that, give you the result, but back and forth, you keep talking to the main agent, which is the chatbot. So yeah, personal assistant. Then we have research workflows. If you need to research different domains and synthesize information from all those different sources, yeah, this is perfect for it. You want an agent that finds information, an agent that analyzes, an agent that interprets. Your sub-agent's pattern can have the main agent doing the tasks sequentially, from researcher to analyst to writer. Another thing is customer data platforms. Customer data platforms. So you have a CRM agent, and we also have an analytics agent, a reporting agent, just different agents that specify on different customer domains. Also, if you want to do code generation, you can have an agent that specializes in planning, another that specializes in writing the actual code, another that reviews the code. So they all do it sequentially like that. You see, the sub-agents pattern is kind of like very, very flexible. It can work sequentially, it can work in parallel, in different ways. We're going to be seeing other patterns later that they're either sequential or they're either parallel. So just giving you that information ahead to see more reasons why you might want to use the sub-agents pattern for a use case that fits the attributes of this pattern. Also, definitely content creation. You want to have an agent that researches, another agent that takes the research, drafts an outline, and another agent that just writes and edits, or even an agent that publishes. So you can use that for content creation. So yeah, these are common use cases in the real world where you can use the sub-agents pattern. And yeah, that's all for the sub-agents pattern in this video.